Okay, today we are going to be looking at properties of logarithms. What we're doing today is just an Algebra 2 review, so everything should be pretty familiar if you had Algebra 2 in the fall. Now, if you had Algebra 2 last year, it might take you a little bit of time to re-familiarize yourself with these. Now, we talked about exponential form and logarithmic form yesterday, and we saw that they're inverses. And what you need to know today about a logarithm, it's just a fancy way of rewriting an exponent. So to rewrite an exponent, or exponential form, into logarithmic equations, well, first you have to put log. And then your base goes right here as a little subscript. And then your answer goes right here. And the answer, or exponent, goes right here. So this is the base, this is the answer, and x is the exponent. Now that one's a little bit confusing, and when I teach Algebra 2 academics, this is something we talk about in academics. And instead of using the n and the x, we do log base b of a is equal to e. Now if you notice, after the word log, what word is this? Base. So B stands for the base, A stands for the answer, and E stands for the exponent. So to use a little bit of the lingo that's familiar to us, base stands for base, answer, exponent, in that order. Okay, now for logarithmic properties. The first one is the product property. And we use these properties to combine multiple logarithms into a single logarithm, or to take a single logarithm and separate them into multiple logarithms. So if you notice, here we have a single logarithm. What operation is happening with m and n? They're being multiplied. And if you want to separate the two logs for m and n, you change multiplication to what operation? Addition. And then the quotient property. If you have division, what operation do you switch it to? Subtraction. And then the power property, what the power property does, it just takes the exponent and pulls it out in front as a coefficient. So the x for the exponent is put right here for the coefficient. This next one, the change of base, we really don't use it that often. And that's because we have inspires that will do this for us. But we talked about this yesterday when we had the log base 2 of x. I told you that if you're using an 83 or 84, when you're trying to graph that, you would have to do log of x divided by log of 2. And I wrote it horizontally, but they have it written vertically. But it's the same thing. So you do the log of n divided by log of b. Now, we really don't use it that often. And then the last property, this is the main property we'll be using, and that's the property of equality. And you notice we have log base b, log base c. And what does this symbol mean? Equal. So if the logs are the same or equal, what does that tell us about m and n? They are also equal. So if the bases are the same, then m and n are also the same. Okay, so now we're going to utilize those properties. And for problems 1 and 2, it says to write each of the following as one logarithm. Now, when you're writing these as one log, go from left to right. So I'm going to start by combining the first two logs together. So if you have addition, what operation do you change to? Multiplication. So keep the base the same. So this would still be log base 3. And I need to multiply x and z. And when I multiply x and z, that would be xz. And again, my goal is to get to a single logarithm. So I have two of them that need to be combined together. And if you have subtraction, what do we change that to? Division. So this would be log base 3 of xz divided by y. So whatever is first becomes the numerator, whatever is last becomes the denominator. And I have it down to 1 logarithm, so that's the answer for number 1. Now for number 2, we'll have to use the power property. So if you have a coefficient in front of your log, you need to put it back as the exponent. So here, the 3 needs to go right here, and we'll have 4 cubed. Same thing with the 1/2, that coefficient, put it back to the exponent position, so we'll have x to the 1/2 power. So doing that, this will give us log base t of 4 cubed plus log base t of x to the 1/2 plus log base t of z minus log base t of 3. And now I'm going to do several steps in one. So I want to go ahead and combine all 3 of these together as one unit. So if I have addition, what operation do I change it to? Multiplication. So keep the log base t. And I need to multiply, well, what is 4 cubed? 64. So this would be 64 times x to the 1/2. Oops, that looks like x and 1/2. So make sure your exponents are up in the air. So here I'll just have to do the diagonal. So it looks like it's an exponent. So x to the 1/2 power, and then that needs to be multiplied by z. And I'll go ahead and keep going with this. So after I've taken care of all the addition, now I've gotten to the subtraction. So for subtraction, what do I change to? Division. Now all of that group needs to be divided by 3. So addition changes to multiplication, and subtraction changes to division. Okay, 3 and 4, it says write each of the following as separate logarithms. So now we're going backwards. Now we have a single logarithm. Now we need to break it up into separate logarithms. So what you need to do is you need to go top to bottom. So start with your numerator. And what operation is happening in the numerator? Multiplication. If I have multiplication, which operation do I change it to? Addition. So all 3 of these need its own log. So this would be log base b of 3 plus log base b of x plus, technically this would be log base b of y squared, but don't leave it as y squared. What do I need to do with that 2? Use the power property, and that 2 needs to become the coefficient. So that needs to be 2 times the log of log base b of y. So that took care of the numerator. Now for the denominator, we are dividing by z. So if I have division, what operation do I change it to? Subtraction. So now we need to subtract log base b of z. So go top to bottom when you have one single logarithm. Same thing for number 4, go top to bottom. So you start with the numerator. And what's happening, what operation is happening in the numerator? Multiplication. So if I have multiplication, what do I change it to? Addition. So this would be log base t of 4 plus log base t. That's x to what power? X to the 1/2. But should I leave that 1/2 in the exponent position? No. What do I do with the powers? Make it as a coefficient. Plus, and that last one, instead of writing log base t of y cubed, what should that be? 3 log base t of y. So all of that for the numerator. Make sure the powers go out front as the coefficient. Now, we need to take care of the denominator. So for the denominator, if I'm dividing, what do I need to change to? Subtracting. And how many logs need to be subtracted here? Two. So, since I have more than one, I'm going to group these bottom two in parentheses, so the denominator stays together. So that would be log base t of 3. And what operation is happening with 3 and m?
Plus.
They're being multiplied, so I need to change it to addition. And we need to add to that log base t of them. Okay, the next section, we need to solve these logarithms. So when you need to solve, just convert to exponential form. And remember, log of base. What is b? Base, what is a? Answer, and what is e? Exponent. So convert to exponential form. So looking at number 5, what is the base? X. What is the exponent? 3. And what is the answer? 64. So now we just have an equation to solve. So x is being cubed, and the inverse of cubing would be?
Cube root.
Cube root both sides. So the cube root of x to the third is x. And what's the cube root of 64? 4. Next one, number 6. The base is missing, so if the base is missing, it's understood to be what value?
10.
Base 10. So our base is 10. What is the exponent? X. And what is the answer?
10 to the 1 half.
Square root of 10. And yes, somebody said that this is 10 to what power?
1 half.
1 half. And that's how you would solve. So if x is an exponent, you need to get like bases. So the like base for 10 and square root of 10 would be 10. And if the bases are equal, what does that tell me about the exponent? They're equal. So the answer is just x equals 1 half. Number 7, again, convert to exponential form. So for number 7, what is the base? 4. What is the exponent?
X.
X. And what's the answer? 1/4.
1/4.
Now, if x is an exponent, try to get a like base. So what is the like base between 4 and 1/4? 4. So 4 to the x is good. Instead of 1/4, that's 4 to what power? -1. So the bases are equal. What does that tell me about the exponent? They're equal, so the answer is what? X equals -1. Number 8, what is the base? 2/3. What is the exponent? X. And what is the answer? 27/8. Now to solve that, we need like bases. So what would be the like base there? 2/3. So this would be 2/3 to the x power is good. But this one would be 2/3 to what power? -3. So then what is 2 cubed? 8. And what is 3 cubed? 27. So if I just cube it, that would give me 8/27. Then in order to flip it, instead of +3, we need to make it to -3. So if the bases are equal, the exponents are equal as well. So what is our answer? X equals -3. Next one, number 9. Now we have logs on both sides. So notice on the left side, this is log base 8. On the right side, this is also log base 8. So we're going to use the property of equality. So if the bases are equal, what does that tell me about what's in the parentheses? They're equal. So set what's in the parentheses equal. So 5x plus 3, set it equal to 45 minus 2x. Now we need to solve. So what would we do next?
Add 2.
Add 2x to both sides. What's 5x plus 2x? 7x plus 3 equals 45. What's next?
Subtract 3.
Subtract 3 to both sides. So 7x equals 42. Divide both sides by 7, and the answer is 6. Now, when you have logs, you need to make sure that you check your answer. And let me go back to the very beginning. And right here, the value for n has to be greater than 0. It can't be negative. So the value for n cannot be negative. So that's what we need to check for. We need to make sure that value for n is never a negative. So if I put a 6 here, what's 5 times 6? And 30 plus 3? 33. So that's not negative. So 6 is good so far, but check it in both places. If I put a 6 here, that would be 2 times 6 is 12. And what's 45 minus 12? 33. So both of those are positive. So 6 is the solution. Now, if we put in a value and it gave us a negative, then it would be an extraneous solution. But you have to check that. We will have some cases where it's extraneous, and we'll see that. Okay, for number 10. If you have more than one log on the same side, you need to combine them together using our property. So if you have a coefficient in front of the log, what do you need to do with that coefficient?
Make an exponent.
Make it the exponent. And then if you have subtraction, what do you change that to?
Division.
Division. So we'll do all of that in one step. So this would be log base 5, and that would be x cubed needs to be divided by 4. That equals log base 5 of 16. So now we've used that property of equality again. So notice we have log base 5, log base 5. So the bases are equal. These values are equal as well. So take x cubed divided by 4. That equals to 16. And solving, we need to multiply both sides by 4. So that gives us x cubed equals 64. And the inverse of cubing would be
Cube root.
cube root. So cube root both sides. And what is the cube root of 64?
4.
4. Now again, you do need to check your answers to make sure the end value is not negative. So if I put a 4 here, is that fine? Yeah, it's not negative. So 4 is a real solution. Number 11. Again, if you have more than one log on the same side, combine them together. So we need to combine these two logs. If I have subtraction, what operation do I change it to? Division. So this would be 4x plus 10. Needs to be divided by x plus 1. Now, do we have logs on both sides? No.
You sure don't?
No, we don't. So we cannot use the property of equality. So if you only have one log, convert it to exponential form. So all you have is one log, convert it to exponential form. So converting that to exponential form, what is the base? 2. What is the exponent? 3. And what is the answer?
4x plus 10 over x plus 1.
4x plus 10 over x plus 1. And 2 cubed is 8. So 8 equals 4x plus 10 over x plus 1. And to solve this, I'm just going to make it into a proportion by making it 8 over 1. And when I cross multiply, that would give us 8x plus 8. And for the other cross product, we need to multiply 4x plus 10 by 1. That gives us 4x plus 10. solve for x, so subtract 4x to both sides. That gives us 4x plus 8 equals 10. Subtract 8 to both sides, so 4x equals 2. And dividing both sides by 4, we get x is equal to 1/2. Now always check it to make sure the end value is not negative. So if I put 1/2 right here, would that give me a negative? No. If I put 1/2 right here, would that give me a negative? No. So 1/2 is a real solution. Okay, number 12. I want you to do number 12. Combining these into one single log. If I have addition, what do I change that to? Multiplication, so x times 2 would be 2x. And if I have subtraction, I change to division. So 2x needs to be divided by 5. That equals log of 8. The bases are equal, so these values should be equal. So set 2x over 5 equals to 8. Multiply both sides by 5. That gives us 2x equals 40. And divide both sides by 2. That gives us x equals 20. And make sure you check it. If I put a 20 here, does that make it negative? No. So 20 is the real solution. Okay, number 13. Again, if you see more than one log, combine them together if they're on the same side. And if I have addition, what operation do I change it to? Multiplication. So we need to multiply the binomial by x, also known as distribute it. So distribute your x. So this would be log base 3. And distributing the x, what is x times x?
X squared.
X squared, and x times negative 8.
Negative 8x.
Negative 8x. And that equals log base 3 of 9. Now we'll use the property of equality, so the bases are equal. These values are equal as well. So x squared minus 8x, that is equal to 9. What type of equation is that?
Perfect square trinomial.
Quadratic.
Oh.
So if it's quadratic, we can solve by quadratic formula, completing a square, factoring. What we need to do is we need to get that in standard form. So everything needs to be moved to one side. So we need to subtract 9 to both sides to get it in standard form. So x squared minus 8x minus 9 equals 0. Now you can solve by quadratic formula or solve by factoring. Does this one factor?
Yes.
Yes. What two numbers multiply to negative 9? And add to negative 8.
Negative 9, positive 1.
Negative 9 and positive 1. And then when we set those factors equal to 0 and solve, what would be the answer for the first factor? X is equal to positive 9. And for the second factor, this would be x is equal to negative 1. Now, I do need to check those answers to make sure the end value is not negative. So if I put a 9 here, that's good. If I put a 9 here, that's good as well. But what about the negative 1? So 9 is an answer. But what about negative 1? Would that work? No, that gives us an end value that's negative. So that one, throw it out. And this one's called an extraneous solution.
That sounds
So
okay.
we got that answer when we were solving, but when we tried to go back and check our work, it didn't work. So it's an extraneous solution. So don't include it as part of your answer. The only answer is 9. And number 14. How is number 14 different?
It's ln.
Yeah, we're using natural log, but it's still logarithm, so same properties we've been using. So if you see more than one log on the same side, combine them together. So if you have addition, what operation do we change it to? Multiplication. So we need to distribute the x. So this would be natural log, and x times x is x squared, and x times 2, 2x. And that's equal to natural log of x plus 6. I want you to finish number 14. Okay, so we have the same log. They're both ln's, ln. So these values should be equal. So set x squared plus 2x equal to x plus 6. And what type of equation is that? Quadratic. So if it's quadratic, move everything to one side. So we need to subtract x to both sides and 6 to both sides. So that would be x squared plus x minus 6 equals 0. Now you can do quadratic formula, but this one factors. And what two numbers multiply to negative 6 and add the positive 1? Positive 3 and negative 2. So when you set the factors equal to 0, what would be the first solution? Negative 3. And what's the second solution? Positive 2. Now check your answers to make sure none of them give you a negative. But can I put a negative 3 right here for x? No. So that one is extraneous. Throw it out. It's not included in the answer. But check the 2. If I put a 2 here, it's positive. If I put a 2 here, it's positive. If I put a 2 here, it's positive. So for that one, the only answer is positive 2. Okay, I want you to do number 15. If you have more than one log, combine them together. If you have the coefficient, what do you do with the coefficient?
Make it the
Make
exponent.
an exponent. And that would be 2 cubed. And what's 2 cubed? 8. If you have addition, what do you change that to? Multiplication. So 8 needs to be multiplied by 4. And that answer, if I get to subtraction changes to which operation? Division. So 8 times 4 needs to be divided by 2. And what's 8 times 4? 32. And what's 32 divided by 2? 16. So what's our answer? 16 is the answer. Now check it to make sure it doesn't give you a negative. The only place I need to put it in is right here. And that's good because it's positive. So 16 is the answer. Number 16, if you see more than one log on the same side, combine them together. So if you have addition, what do we change that to? Multiplication. So we need to distribute the x. So that would be log. And x times x is x squared, and x times negative 3. Negative 3x. And that's equals 1. Can I use the property of equality here? No, because we have logs on both sides. No. So if you only have one log, how do you solve that? Yeah, convert to exponential form. So what is the base? 10. What is the exponent? 1. And the answer is? X squared minus 3x. What type of equation is that? Quadratic. So to solve our quadratic equations, get it in standard form. And we will subtract 10 to both sides to get it in standard form. So 0 equals x squared minus 3x minus 10. Does that one factor?
Yes.
Yes. What two numbers multiply to negative 10 and add to negative 3? Negative 5 and positive 2. So what is the first solution? 5. What's the second solution? Negative 2. Which one of those is extraneous? Negative 2, because can this be a negative right here? No. But check the 5. 5 is good. 5 is good. So 5 is the only real solution. Number 17. If you have subtraction, what do you change that to? Division. So this would be natural log of x plus 1 divided by x minus 2. Not equals natural log of x. What do I do next? Yes. I need to use the property of equality. So set these equal. So this would be x plus 1 over x minus 2 equals x. If I put that over 1, I can change it to a proportion and cross multiply. So if I multiply these, distribute the x, and what's x times x? X squared, and x times negative 2? Negative 2x. Set it equal to the other cross product. And x plus 1, when we multiply it by 1, it's just x plus 1. And what type of equation is that? Quadratic. So to solve a quadratic, get it in standard form. So we need to subtract the x to both sides and subtract 1 to both sides. So that gives us x squared minus 3x minus 1 equals 0. Does that one factor?
No.
No. So if it doesn't factor, what are we forced to do? Quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What do I put for negative b?
Positive 3.
Positive 3 plus or minus the square root. And what do I put for b?
9.
Negative 3 squared minus 4 times, what do I put for a? 1. And what do I put for c?
Negative 1.
Negative 1. All over 2 times a, so this is 2 times 1. Now this, everything we're doing today is without a calculator. And this will be on the no calculator portion of your test Tuesday. So, doing a little bit of simplifying. working under that square root. What is negative 3 squared? 9. And when I multiply these three numbers, what do I get? Positive 4, and 9 plus 4 is 13. And in the denominator, 2 times 1 is 2. How many answers do I have there technically? 2. Now, if your radical is simplified, you need to simplify that radical. But our radical there doesn't simplify. But since we do have 2 answers, we do need to check them. But since this is without a calculator, well, do you know what is the square root of 13? No. Well, what is the square root of 9? 3. And what is the square root of 16? 4. So where would square root of 13 fall? Between those two, and it's going to be a little bit closer to 16 than to the square root of 16 than to the square root of 9. So I don't know exactly what is the square root of 13, but I do know it's a number between 3 and 4, right? So let's just say it was 3.5, and it's not, but let's just say it was. Well, what would happen if I did 3 minus 3.5? What would happen? It would become a negative, and a negative divided by a positive becomes what? A negative divided by a positive would be a negative. And if I go back to my problem, can this value right here be negative? No. So how many solutions will I have here? One. Only one. So the only solution will be 3 plus the square root of 13 over 2. So I will not have the plus or minus, because if I use the minus, then that x would be negative when I substituted it back in. And the last one, number 18. What do we need to do here? Divide. So this would be log. And subtraction changes to division. So x squared minus 36 over x minus 6 equals log of 4. Do I want to deal with a quadratic?
You can reduce.
No, not after doing quadratic formula. I don't want to do that. But what do you notice up here in the numerator? It is the difference between. Yeah, so if we can factor, do yourself a favor and factor it. So that is a difference of squares, so we'll factor that as x plus 6, x minus 6, over x minus 6 equals log of 4. And what happens with the x minus 6's? They cancel. Now I can set them equal, and this would be x plus 6 equals 4. So what's the answer for x? Negative 2. And what happens if I put a negative 2 right there? It becomes negative, so that is extraneous. Throw it out. So what's the solution? No solution. No solution. So if your solutions are extraneous, make sure you mark it as no solution.